Hello. Today we're going to learn section 3.6, the chain rule, which is so named because it's used for composed functions that are interlocking. You can see I've drawn this nice chain for you here. So, to begin, we need to review function composition. So please do the quick review on page 153, and you can restart the video once you've finished. Great job. Okay, so you know how to find the derivative of something like x squared or sine of x, but what about something a little more complex? What about the derivative of x cubed minus 5x quantity squared? Well, you could use the power rule like you've been taught. Just bring down the 2. That could be the derivative. Let's check it. So if we make x equal 1, then we get the answer that equals -8. Now let's check this by typing in to your calculator that. Please take a moment to do this. You should get the answer of 16. Obviously, these do not match, so we are in need of an adjustment factor. This is where the chain rule comes in. So, we can define this as a composition of two different functions, f of g of x, where f of x equals x squared and g of x equals x cubed minus 5x. So we know how to find f prime and g prime separately, but in order to find the derivative of the whole thing, of f of g of x, we need to somehow combine them. And we combine them using the outside-inside rule, where the outside is f of x and the inside is g of x. So to do this, to find the derivative of x cubed minus 5x quantity squared, we have to find the derivative of the outside first, which is the inside squared. So we bring down the 2 using the power rule. We leave the inside alone. And then we multiply this by the derivative of the inside, which is 3x squared minus 5. So, then simplifying a little, we get 6x squared minus 10 times x cubed minus 5x. So let's check this against what we plugged into the calculator. Plug in 1. And we get -4 times -4 equals 16. Let's look at another example. This example is going to be y equals sine of x squared plus x. So, the outside function, sine of x, we can see that the inside function is x squared plus x. So, using the outside-inside rule to find dy dx, we take the derivative of the outside, which is sine, and derivative of sine is cosine, and we leave the inside alone. Then, multiply by the derivative of the inside, so multiply by 2x plus 1. Now, the outside, inside rule, broken down to the general rule, is if y equals f of g of x, then dy dx is equal to f prime of g of x multiplied by g prime of x. Now please try number 13 on page 153. Great job. Now, let's look at the chain rule in a slightly different way. If y equals 6x minus 10, we can factor out a 2 so that y equals 2 times 3x minus 5. And then we can further break this down so that y equals 2u and u equals 3x minus 5. So we know how to find the derivative of all of these. dy dx here is equal to 6. Differentiating with respect to u, derivative is 2. And down here, du dx equals 3. So, rearranging this a little bit, dy dx equals dy du times du dx. You can see that the du's cancel. And you're left with dy dx. Now remember that in Leibniz notation, this is not a fraction, but fraction rules do apply. At this time, please try exercise number 1 on page 153, and then take a moment to write down rule number 8 on page 149. Okay, so since all of you are very intelligent and inquisitive calculus students, you're probably wondering how to find the derivative of a composition of functions that has more than 2 functions composed within it. Well, lucky for you, it's time to learn about a 3-link chain. It's actually really simple to learn once you've mastered the chain rule, because you just end up using it more than once. So if y equals tangent of 5 minus sine of 2x, we can see there are 3 functions composed here. The first is tangent, second is sine, and the third, 2x. So, to find dy dx, we take the derivative of the outermost function, which is tangent, so we get secant squared, and remember to leave the inside alone, but to multiply by the derivative of the inside. Which is now, this times 2 comes from the derivative of the inside of this function composition, which is sine of 2x times 2, which is the derivative of 2x. So then, simplifying a little, we get negative 2 times cosine 2x multiplied by secant squared of 5 minus 2x. Please now try number 23 on page 153. Congratulations! You now know how to use a chain rule. This is probably the most widely used derivative rule, and you will use it quite often. This video has been brought to you by Jennifer Bluen.